Alright guys, here's how you do your practice quizzes on Edmodo. This is last year's quiz for Chapter 16, Acids and Bases. Number 1, it wants you to figure out the pOH of a 2.5 times 10 to the negative 4 molar solution of KOH. KOH is a strong base. You know this because it has OH in it. So you can find the pOH by taking the negative log of the concentration of the base. So the negative log of 2.5 times 10 to the minus 4 equals 3.6. That's the pOH of that base, of that concentration. So there it is. Now what is the pH of the same solution? Well, I told you that 14 equals the pH plus the pOH. So therefore the pH would equal 14 minus the pOH. 14 minus 3.6 would be 10.4. Go on to number 2. What is the pH of a 3.6 times 10 to the negative 3 molar HCl solution? This is a strong acid. You will learn your strong acids and bases by looking at the notes. If you see an OH, it's a strong base. If you see just an H before a nonmetal or a polyatomic ion, it's going to be strong acids because you're only working with strong acids and bases. When you get to AP Chem, you'll work with weak acids and bases. The pH equals the negative log of H plus. The P of anything is the negative log of that thing. So the P of H is the negative log of the H plus ions. The negative log of 3.6 times 10 to the minus 3 is 2.444. Now I have 3 sig figs here, and I have 4 sig figs in my answer. That's okay. When you're working with pH, you add another sig fig. You report your answer to one more decimal place. It's because you're working with a logarithmic scale. Everything else follows regular sig fig rules, except for pH. What is the pOH of the same solution? Again, pOH equals 14 minus the pH, so it's just 14 minus 2.444. It's 11.556. What is the KW? What is the value of KW? KW for pure water or for water at 25 degrees Celsius is 1 times 10 to the negative 14. All right, it's going to be a constant value for water at 25 degrees Celsius. It is KW equals the hydrogen ions concentration times the hydroxide ion concentrations, and at 25 degrees Celsius, both of their values are the same. They're 1 times 10 to the minus 7 for pure water. So 1 times 10 to the minus 7 squared is 1 times 10 to the minus 14. You just add the exponents. So then what is the hydronium ion concentration? Hydronium is simply this, H3O plus. It's the same thing as saying H plus. They're used interchangeably when you're talking about acids and bases. So here you have your hydrogen ion concentration. It is 1 times 10 to the minus 7, right there. And the hydroxide ion concentration is the same thing, 1 times 10 to the minus 7. All right, number 4. What is the pH of a solution that has... Okay, sorry, I'm just going to go back up here. The reason that this is because water, as I showed you on the board, water is amphoteric. It goes through deprotonation. It becomes H3O plus and OH minus. And the concentration of each of these is 1 times 10 to the minus 7. And this one is 1 times 10 to the minus 7. And these are, that's molarity. It's supposed to be an M. It's a terrible M. I ran out of room to write that. Okay. But 1 times 10 to the minus 7 for both of these. Okay? For the OH and for the H3O plus in pure water. Let's see. Number 4, what's the pH of a solution that has a volume of 700 milliliters and has 20 grams of nitric acid, HNO3, dissolved into it? Nitric acid weighs 63 grams for every 1 mole. You have 20 grams of it. That means you have 3.17 times 10 to the negative 1 moles. Divide that by 0.7 liters, and you get the concentration of your H plus ions because it's a strong acid, so it dissociates 100%. The negative log of that concentration will equal your pH. So the pH equals 0.34 when you adjust it to the correct sig figs. What's the pOH of a solution that has a volume of 800 milliliters and 20 grams of lithium hydroxide? Lithium hydroxide is a strong base. You know this because of the OH. So you have then 20 grams divided by 24 grams per mole of the lithium hydroxide. You get 0.833 moles of lithium hydroxide divided by 0.8 liters. Gives you a molarity of 1.042 molar of OH ions. Because I'm not really concerned with the lithium, I just want the OH. So we take the pOH equals the negative log of that number, and that's 0.0117. 14 minus the pOH equals the pH, so my So my pH equals 14.02. Number 6, what is the hydronium ion concentration of a solution that has a pH of 4? That has a pH of 4, the hydrogen ion concentration equals 1 times 10 raised to the negative 4. How do I know this? Because hydronium ions concentration will equal 10 raised to the negative pH. The pH is 4, so 10 raised to the negative 4 equals 1 times 10 to the negative 4 molar. You could also say that your hydroxide ion concentration equals 10 raised to the negative POH. Both of these will work out. Oops, sorry. All right. Number 7, if you dilute 20 milliliters, so M1V1, M2V2, you divide 20 milliliters of 1 times 10 to the negative 4 molar solution. What is the pH? And has that has a pH of 4, so the pH is already 4. How did I get 1.4 times 10 to the negative 4 molar? I got it right here. I got it from my previous answer. Because the pH was 4 in the previous question, right? And then the concentration of the hydrogen ions was 1 times 10 to the negative 4. So there you go. My new concentration is X, because I have 600 milliliters. X is equal to 3.3 times 10 to the minus 6. That is your hydrogen ion concentration. The negative log of that equals your pH. The pH equals 5.48. So less acidic, which makes sense because you diluted it. So it is less acidic. Number 8. If you take 50 milliliters of 0.75 NaOH solution to neutralize 100 milliliters of HBr, so you write out your balanced equation. And notice that it's in a 1-to-1 ratio. So I multiply my liters times my molarity to get my moles of my NaOH. My moles of my NaOH can be converted into my moles of HBr very simply. Times 1 divided by 1. Same number of moles. See the arrow? Right there? Same number of moles. Divided by 0.1 liters. Why? Because the HBr was in 100 milliliters of solution. And I get my molarity of the HBr solution. Is a pH of POH of 2 acidic or basic? So for pH, right? For pH, it's 7 is neutral, 14 is basic, and acidic is 0. However, for POH, all right, 7 is still neutral. All right, 0 is now basic, and 14 is now acidic. So, because you have a POH of 2, that's over here, and that's basic. Number 10, if you created a solution by adding 1.2 times 10 to the minus 2 moles of HI and 2.1 times 10 to the minus 3 moles of LiOH until the final volume is 1 liter, what is the pH of the solution? Now, what you have is HI reacting with LiOH. LiOH is a base, HI is an acid, so they will produce water and a salt. The limiting reactant is the one that's available in less moles because it's in a 1-to-1 ratio. 2.1 times 10 to the minus 3 moles of LiOH is the limiting reactant. The excess would then be the hydroiodic acid. So take the difference of these two numbers, and I get 9.9 times 10 to the minus 3 moles of HI left over. That's how much I have of the leftover acid. I divide that by 1 liter of solution. That's my molarity, 9.9 times 10 to the minus 3. Take the negative log of that, and I will get, the negative log of that equals the pH, which is 2. Alright guys, you have 4 versions of this practice quiz. The quiz you will take after spring break will not be exactly the same, but it will be on all the same material. So practice these Edmodo quizzes, practice your worksheets that I gave you, and read through all the notes and all the videos online until you feel comfortable that you understand this material. Good luck.